In this lecture, I will discuss some of the properties of Laplace transform. In the previous lecture, I have already discussed about the concept of Laplace transform, how you can get Laplace transform from the Fourier transform. And also I have derived Laplace transform of some important function. As I have discussed in the previous lecture, Laplace transform of any function ft will be equal to fs, function of s, and this fs can be calculated from this integral 0 to infinity ft e to the power minus st dt. This is the mathematical expression through which you can derive Laplace transform of any function ft. And second thing is Laplace transform basically transform time domain signal in S domain. Here S is basically a complex number sigma plus j omega, where sigma is very small, or you can say tending toward 0. So this concept already I have covered in the previous video. In this video, I will discuss some of the properties of Laplace transform. Let us consider its first property, which is shifting property. If Laplace transform of any signal ft is fs, then if you will multiply this signal with exponential term e to the power minus alpha t, then its Laplace transform will shift and it become fs plus alpha. So if you have an idea of Laplace transform of ft, then by using this property you can determine the Laplace transform of e to the power minus alpha t ft. For example, you know the Laplace transform of sine omega t. Laplace transform of sine omega t is omega by s square plus omega square. Now, using this property, you can determine Laplace transform of e to the power minus alpha t sine omega t. In this case, what you will do? Just you will have to replace s with s plus omega. So its Laplace transform will be this. So in this way, if you have an idea of Laplace transform of any function ft, then by using this property, you can determine the Laplace transform of e to the power minus alpha t ft. Now, the proof of this statement is here. You can see if Laplace transform of ft is fs, then Laplace transform of this will be fs plus alpha. How you can get this statement? So for this, I have considered Laplace transform of ft, which is equal to this. And what will be the Laplace transform of this function? E to the power minus alpha t ft. So in place of ft, you will have to write ft e to the power minus alpha t. And here bases are same. So the power will be added together. You will get this result. And if fs is ft to the power minus st, then what will be this? This will be fs plus alpha. So in this way, you can prove this statement. So this is shifting property 1. And there is another shifting property also, which you can say shifting property 2. Shifting property 2 is if Laplace transform of any signal, ft is fs. This is very important property. Then the Laplace transform of ft minus t0, ut minus t0. Here u is the unit step function, will be equal to e to the power minus t0s fs. So if you will shift signal in time domain, then one delay term or exponential term will be multiplied in its Laplace transform. This is shifting property 2. And this property, you can easily prove this property. Just you have to take Laplace transform of this function. And as you know, Laplace transform of any function ft is 0 to infinity ft e to the power minus st dt. So if you want to calculate Laplace transform of this function, then in place of ft, you will have to write ft minus t0 ut minus t0 in place of this. So by considering, uh, you can see here what will be the Laplace transform of this. So in place of ft, you will have to write this e to the power minus st dt. And now, as you know, this term will be 1 for t greater than t0. Otherwise, this term will be 0. So the limit of integration will change. Now limit of integration will be t0 to infinity, because before t0 the value of ut minus t0 will be 0. So you will start this integration from t0, and after t0 the ut minus t0 will be equal to 1. So it will be ft minus t0 e to the power minus st dt. Now you can substitute t minus t0 equal to u, and then dt will be du. And when t equal to t0, then this limit will be 0. And when t become equal to infinity, then the limit in terms of u will be infinity. So the limit will change 0 to infinity, and this become fu e to the power minus s, and in place of t, you can write u plus t0. And in place of dt, you will have to write du. So this is the integration with respect to u. So e to the power minus st0s, e to the power minus st0 will be constant for this integration, because this is integration with respect to u. So this term will come outside the integration, and inside the integration there will be fu e to the power minus su du. And what is this? This is Laplace transform of ft, which is fs. So you can write this. So in this way you can prove the Laplace transform of ft minus t0 ut minus t0. So this is shifting property 2. And now, differential property of Laplace transform. According to differential property of Laplace transform, if you have an idea of Laplace transform of any function ft, which is fs, then what will be the Laplace transform of its differentiation? What will be the Laplace transform of dft by dt? Means with the help of this property, you can determine the Laplace transform of differential of the function. And its derivation is also very simple. As you know, Laplace transform of any function is given by this integration. And now you will have to use integration by part. You can use integration by part. What is integration by part? How you will calculate integration of a product of two functions? You will have to write it is first function into integration of second. Integration of second function will be e to the power minus st, and with respect to s, you are integrating with respect to t. So in the denominator there will be minus s. So first function into integration of second minus integration of dc of first function, into integration of second function. This is second function, and integration of second function will be e to the power minus st divided by minus s dt. And in this you will have to put integration limit 0 to infinity. So you will get this result. And now when you will substitute the value of upper and lower limit, then what you will get? you will get uh, when you will put infinity in place of t, then first term will be 0. And when you will put t equal to 0, then this will be f0 divided by minus s. And this minus will be plus. So you will get f0 by s. And this minus will be plus. So you will get here 1 by s 0 to infinity f dash t to the power minus st. And what is this? This is Laplace transform of f dash t. This is Laplace transform of f dash t, which I am going to calculate. So when you will solve this expression, you will get this s and this s will multiply here. So you will get sfs, and this term will be, when shift this side, then this will be minus f, and this term will be 0 to infinity f dash t e to the power minus st dt. And what is this? This is the Laplace transform of f dash t. So in this way, you can calculate the Laplace transform of differential function, differentiation. So if Laplace transform of ft is fs, then Laplace transform of f dash t equal to sfs minus f0. Now its fourth property is integration. Fourth property is integration. But you must remember the Laplace transform of f dash t will be sfs minus f0, because I am going to use this concept for deriving this property. So if Laplace transform of any function ft is equal to fs, then Laplace transform of its integration will be fs by s. Now how can you prove this statement? Just you have to assume this is equal to phi t. And now differentiate this. You will get this result. And what will be the Laplace transform of differentiation? What will be the Laplace transform of this? Laplace transform of this will be equal to s phi s according to this property. Minus phi 0 is also here. But in this derivation, I have assumed this is equal to 0. This is equal to 0. So I have considered Laplace transform of phi dash t is equal to s phi s. And what is phi dash t? It is ft basically. So Laplace transform of f dash t means you are calculating Laplace transform of ft. So which will be equal to fs also. So in this way you can get phi s equal to fs by s, where phi s is Laplace transform of phi t, means Laplace transform of this integration. In this way you can prove this statement. So in next video I will discuss how the Laplace transform will change when you will multiply function with time, or when you will divide Laplace function with time, then how the Laplace transform will change.